So let's go back to the initial problem that we had at the beginning. We want to do the analysis on the movie data. Let's start with the very first example, a simple analysis. Let's say I want to find the rating averages of all the movies over the year. Let's start with that. So when you start analyzing the data, the first thing you want to know is what does your data look like? Again, we are putting this in the context that you have massive data, so you are not going to sit on your computer and trying to hack the data or trying to have the data or trying to tell the data. You want to be able to do that within the context of Hadoop. So let's see. SSH, DSCIU, 001, HDFS, DFS, cat. The files is in repository, that's movie lens. Fortunately, this has a README. So I'll start with DFS. I'll start with README. Repository. Oh. Anyone not able to run this command? So through this DFS command, you can start to view documentation that go with the movie. This movie is very nicely formatted, and the structure are all listed in this file.
I mean, the data set, not the movie, right?
Yeah. So in some cases, you might not be so lucky and you have a massive data set and you have no metadata information to go with it. So you actually have to dive in and look at the data and don't do a more on a large data set or the on Python. So SSH, DSCIU, 001, HDFS, DFS. Let's cat this file. Don't hit enter yet. You'll be sorry if you hit enter. Movie lens, rating.csv. Do we want to run this command? We are facing with a line that has potentially 20 million ratings, so we do not want to cat the entire file. What we can do is, so I assume you guys went through, many of you sit through the software carpentry, so we should be able to pipe it. And to combine it with Linux capability, let's say I just want to look at the first 10 lines of this data set. What was the small time? Okay, so you can see here, I'm in the cat, hide it to cat only reading the first 10 lines. So it breaks the cat command halfway through, so it doesn't print out the entire massive data set, and you can still look at the data, and you can look at more data as you need. The cat error message and the initial error message is somewhat annoying, so you can make them go away by do this. So pipe all the error message out onto dev node. So that way we only have the actual data left.
What that does is it sends the error messages into Oblivion, so you won't be shown any error messages if you command ended up having an error of some sort. But he showed you that so that you don't have to see all that other clutter when you really want to focus on your output.
So now you can see this is the command separated data set with the first row, with the column representing user ID, movie ID, rating, and timestamp. So in the next part, let's start to look at, okay, let me put up the writing in here also. So writing program in Hadoop MapReduce is very restrictive. Everything that you do, you have to write it in the context of a map function and a reduce function. So how do you design a map and reduce function? I have taught this module for my 3620 courses over the last 4 to 5 years, and there are actually a lot of very competent students in the class still having trouble changing their mindset from a standard functional programming and objective programming language, where you can be very expressive in how you write a program, into being limited into writing mapping and reducing. Everything has to be put into the context of map and reduce. Otherwise, it doesn't work on the Hadoop framework. So I have found that the easiest way to think about map reduce is actually work backward from the result. What do you want to get out? So MapReduce essentially is a data analytic tool. You are trying to process massive amount of data to get something that you want. So let's start backward. Let's start with something that you want and go backward to see what you need to reduce and what you need to map. So I want to find the average ratings of all movies. So this implies that my data element at the final result is going to be individual movie with an average rating. That means my key is going to be the movie ID, and my average rating is the average of all ratings associated with that movie. So you have the first set is you have your key and you have your values. Key is movie ID, and the value are all the rating associated with the ID. So this is what, the output of the reducer is movie ID and the average rating. And again, the reducer is responsible for aggregating values for a certain set of data. So that means data coming into your reducer is going to have the context of the key movie ID and all the values associated with that movie ID. So what should be the outcome of your mapper? Yes.
So it would be just the movie ID for the key and just the rating for that particular movie.
Yes.
For that rating entry.
So again, if you look back at this data format, by default, each of the map function is going to apply to a single line data set. That is the default data rating for Hadoop MapReduce. So you have movie ID and rating. So after your mapping process, when it processes a single line of data for each block, it should emit the key as the movie ID and the value as the rating.